Alice and Bob do a certain job in 2 hours. Alice and Charlie do the same job in 3 hours. Bob and Charlie do the same job in 4 hours. How long will it take if all three work together? Assume that they work at the same rate, no matter who they are working with. This is what is known as the three coworkers problem, or the working together riddle. If you want to figure out the answer yourself, go ahead and pause the video. If you don't, or already have, and you want to know what my approach is, just keep watching. Obviously, we don't know what the job is, or what has to be done to accomplish it, but we don't actually need that information to solve the problem. However, to use math to solve the problem, we need some numbers to work with. So let's say the three people work at a bracelet factory, and that fulfilling a recent order requires assembling 120 bracelets. To calculate how long it takes all three to do the job, we need to determine the combined production rate for all three workers. Referring to the figures given in the problem, we find that Alice and Bob take 2 hours to make 120 bracelets. So 120 divided by 2 equals 60 bracelets per hour. Alice and Charlie take 3 hours to assemble 120 bracelets. So 120 divided by 3 equals 40 bracelets per hour. Bob and Charlie assemble 120 bracelets in 4 hours. So 120 divided by 4 equals 30 bracelets per hour. Now, if we add all this up, we come up with 2 Alice plus 2 Charlie plus 2 Bob equals 130 bracelets per hour. Of course, we actually only have one of each of them, so we divide both sides of the equation by 2. Thus, Alice and Charlie and Bob working together assemble 65 bracelets per hour. If we take the 120 bracelets that need to be assembled and we divide that by the production rate of 65 bracelets per hour, we find that it takes 1.8461538 hours to get the job done. If we multiply that by 60 and round it off to the nearest minute, we find that is 111 minutes, or 1 hour and 51 minutes. You may have noticed it took only 2 hours for just Alice and Bob to assemble 120 bracelets, and when Charlie chipped in, it took only 9 minutes less. Thus, we could say that Charlie's contribution is minimal at best, and you would get the impression that Charlie is quite a slacker. This brings us to the bonus question. What is the relative production rate of each worker? Well, we find that the combined production rate of all three working together is 65. The combined production rate of Bob and Charlie is 30. If we subtract 30 from 65, then we find that Alice's production rate is 35. The combined production rate of Alice and Bob is 60. If we subtract Alice's production rate of 35 bracelets per hour, we find that Bob's production rate is 25 bracelets per hour. If we take Alice and Charlie's production rate of 40 per hour and subtract Alice's production rate of 35 per hour, we find that Charlie's production rate is 5 bracelets per hour. Now, if we take Alice's production rate of 35 bracelets per hour and divide it by Charlie's production rate of 5 bracelets per hour, we find that Alice has a production rate 7 times the production rate of Charlie. If we take Bob's production rate of 25 bracelets per hour and divide it by Charlie's production rate of 5 bracelets per hour, we find that Bob has a production rate that is 5 times the production rate of Charlie. If we take Alice's production rate of 35 bracelets per hour and divide it by Bob's production rate of 25 bracelets per hour, we find that Alice has a production rate that is 1.4 times the rate of Bob. You can see that we made the assumption that the job involved assembling 120 bracelets, but the end result would be the same for any job that needs to be done, whether it is assembling 120 bracelets or digging 240 holes in the ground.